Somewhere far across the dark, a giant world is turning one cheek forever toward a fire. It is a planet the size of Jupiter, that pale striped marble you may have glimpsed through a small telescope, banded in cream and amber and rust. But this one does not keep its distance. It swings so close to its star that a whole year there passes in only a handful of days, and on the face that never looks away, the air glows the dull red of heated metal. Picture it from very far off, from a place where the heat cannot reach you. A sphere of cloud lit on one side to a sullen ember, trailing a faint tail of streaming gas like a comet made of planet, while winds fiercer than any storm on Earth pour the warmth around toward the cold and starless night. There are worlds out there where iron rises into the sky as vapour and falls on the far side as a fine metallic rain. There are worlds so hot that their sunlit face outshines some small stars. And there is one, the very first of its kind anyone ever found, that quietly rewrote everything once believed about how planets are born. What is it like for a world to live that close to a sun? You do not need to hold any of this. There is nothing here to memorize, nothing to keep, nothing that will be missing if it slips away before morning. Let the facts move through you the way warmth moves through a sunlit room, touching you a moment, then passing on, asking nothing in return. Some of these wonders will follow you down into sleep and some will dissolve before you wake, and either way is exactly as it should be. These planets have circled their distant fires for billions of years without a single witness, and they will go on turning whether you remember a word of this or not. So let the mind loosen its grip. Let your eyes close when they wish to. The cosmos keeps its own slow time tonight, and you are welcome to borrow it for as long as you like. Begin with the word itself, with the strange small phrase that names these worlds. Astronomers call them hot Jupiters, and the name holds the whole wonder in two words. Jupiter, because they are giants, globes of gas and not of stone, vast balls of hydrogen and helium wrapped around a deep and dense heart, near enough in size to the largest planet of our own family that you could mistake their dim silhouettes for it, and hot, because they have wandered in to where no giant was ever expected to be, pressed up against the glare of a star until their outer air begins to simmer and shine. The name was almost a joke when it was first spoken aloud, a contradiction that should not exist, a thing too big and too close all at once, the way a snowball has no business resting in an oven, and yet the sky is scattered with them, hundreds upon hundreds already counted, each a giant where theory once swore none could ever be. The contradiction was real all along. We had simply never looked closely enough to see it. How close is close out here is hard to feel until you measure it against home. Mercury, the innermost world of our own sun, sits so near the fire that its dayside bakes to a temperature that would melt lead, and even so it takes 88 days to complete one slow loop around the star. A hot Jupiter would find that orbit lonely and distant. Many of them circle their stars in 3 or 4 days. Some race around in less than a single Earth day, so that a creature standing in that endless light, if such a thing could ever stand there, might watch its sun heave across a sizable arc of sky between one slow breath and the next. The whole of a year, the full turning of what we would call the seasons, compressed into less time than you will spend asleep tonight. Imagine living 100 years and seeing your star return to the same point in the sky tens of thousands of times. A lifetime measured not in long, slow orbits, but in a blur of them, each one over almost before it began. That nearness pours an astonishing amount of heat onto a single face. The day side of these worlds can climb to somewhere between 1,000 and well over 2,000 degrees Celsius, hot enough to make solid rock run like water, hot enough that the air itself begins to glow with its own light, rather than merely catching the light of the star. Think of a blacksmith's iron drawn fresh from the forge, that deep cherry red that means the metal is giving off warmth you can feel from across a darkened room. The upper air of a hot Jupiter shines like that, all on its own, a faint planet-wide glow that no rock or cloud reflects but the heat alone creates. These are not worlds lit only from outside, the way our cool grey moon hangs lit by borrowed sunlight. Part of their light comes from within, an inner fire of pure temperature, so that even the night side carries a dull, ruddy afterglow, like coals that never quite go out. The very first of them ever found turned the whole study of the heavens on its head. In the autumn of 1995, two astronomers in Switzerland, watching a faint and ordinary star much like our own sun, noticed it wobbling, leaning a hair's breadth toward them and then away, again and again, in a steady rhythm of just over 4 days. Something unseen was tugging on it, swinging it gently back and forth like a slow pendulum. That something was a planet near the mass of Jupiter, whipping around the star once every 100 hours, and its name became 51 Pegasi b. It was the first planet ever confirmed circling another star like ours, the first solid proof that the worlds beyond are not a dream or a hope but a plain fact, and the two men who found it, Michel Mayor and Didier Queloz, would one day stand together in Stockholm to receive the Nobel Prize for what that small wobble revealed. A single star refusing to hold quite still, and with it, the door to a galaxy of worlds swung open. What made that little wobble so startling was not only that a planet was there, but that it was there at all, in that particular impossible place. Everyone had expected the first such world to be found far from its star, slow and cold and stately, the way Jupiter circles our own sun across nearly 12 long years. Instead, the first one ever seen was a giant pressed almost against the furnace, finishing a year in the span of a long weekend. It was as if you had searched the dark horizon for the faint glow of a distant lighthouse, and found, instead, a bonfire blazing at your feet. The discovery did not merely add one planet to a list. It cracked the picture everyone had quietly been carrying of how a planetary family ought to look, and into that crack poured a flood of questions that would take decades to begin to answer. Most of these worlds keep one face turned eternally toward their star, the way our own moon keeps one face turned eternally toward Earth. The pull of the nearby star has gripped them so firmly, across so many ages, that their turning and their orbiting have locked together into a single seamless motion, a state astronomers call tidal locking. One hemisphere lies forever in a noon that never ends, bathed in a glare that never dims and never moves from the centre of the sky. The other lies in a night that never lifts, a darkness no dawn has ever crossed, where the star has never once risen above the horizon. There is no morning on a hot Jupiter, and no evening, no slow golden hour, no gathering dusk. There is only the bright side and the dark side, and the long thin seam of perpetual twilight that runs between them like a ring of soft dusk drawn all the way around the whole sphere. On such a world, the day and the year have become the very same thing. It turns exactly once for each single loop around its star, so that one full spin and one full year are one and the same motion, and noon, once arrived, simply never ends. Along that border between the endless day and the endless night, something strange and beautiful is always unfolding. Heat does not like to sit still. It flows always from where there is more of it toward where there is less. And so the warmth piled up on the blazing dayside comes pouring around toward the frozen night, and it pours as wind, but wind on a scale that has no real name on Earth. The fiercest gusts ever clocked in the worst hurricane here would seem a dead stillness there. On these worlds, the air can race from the hot face to the cold one at many thousands of miles an hour, swifter than the speed of sound, a river of glowing gas streaming without end around the planet, always in the same direction, ferrying the day's heat into the dark and never once resting. It is the same simple law that stirs the breeze through your window on a warm evening, hot air rising, cool air sliding in beneath. Only here it has been wound up to a fury that would flatten mountains and set spinning forever. That heat does something else as well, something you can almost feel in your own body as you settle deeper into the warmth of where you lie. When you warm a gas, it swells and grows light. The air inside a hot air balloon expands and lifts the whole basket gently into the sky for exactly this reason. Now imagine that swelling poured into an entire planet. The fierce nearby star heats a hot Jupiter so thoroughly, hour after hour, age after age, that its whole vast envelope of gas puffs outward, bloating the world far larger than its mass alone could ever account for. These are some of the most distended objects in the whole galaxy. Giants inflated like great soft globes, their outer layers loosened and spread by the heat until each planet is wider than it has any right to be. A world swollen and lifted by warmth, riding light around its star. Some of these inflated worlds are so puffed, so light for their size, that they seem to defy good sense entirely. The very lightest of them have a density less than that of cork, less even than the density of plain water. Worlds you could almost imagine, if you ignored the temperature, set afloat in a great enough ocean, bobbing like a cork in a glass. All that bulk, a globe wider across than Jupiter, and yet so little weight packed into so much volume that the whole thing is barely more substantial than a cloud given a shape and an edge. Astronomers sometimes call them puffy planets, and the gentle word is exactly right. They are enormous warm balloons of gas, distended by their nearness to the light, drifting around their stars with almost nothing holding them down, the most insubstantial giants imaginable, vast and weightless at once, like a held breath that happens to be the size of a planet. There is a clean and revealing pattern in just which of these worlds swell the most. When astronomers line up the hot Jupiters and compare them one against another, the rule emerges plainly. The more starlight a world receives, the more bloated and the less dense it tends to become. The hottest, most fiercely irradiated giants are the puffiest of all, while their cooler cousins, set a little farther from their fires, stay more compact and ordinary in size. It is as if each planet were a loaf left to rise in proportion to the heat of its oven, everyone swelling to match the warmth it is given. That tidy relationship between heat received and size attained is one of the strongest clues astronomers have to the hidden workings deep inside these worlds. A single, simple thread connecting the fire outside to the slow swelling within. The hottest of all sit at the far edge of the scale, and astronomers set them apart with a name of their own. They are the ultra-hot Jupiters, and on these worlds the day side does not merely glow. It rises past 2,000 degrees, past 3,000, in the most extreme cases past 4,000. At those temperatures, the ordinary rules of chemistry begin to come apart at their seams. Molecules cannot hold together in such heat. The bonds that bind atom to atom are shaken loose, and substances are torn down into their separate pieces. And metals that on any cooler world would be hard and silver and solid, iron, titanium, magnesium, the very stuff of tools and machines, turn to vapour and rise into the air as a gas. The sky of an ultra-hot Jupiter is laced with the shimmering breath of vaporized metal, glowing in the light of the star, a heaven of evaporated iron where on Earth there would be only thin, clean air. On one such world, the strangest weather in all the known sky has been measured by patient and careful eyes. It is called WASP 76b, and on its blazing dayside the temperature climbs above 2,400 degrees, hot enough to boil iron into a metallic fog and lift it into the air. The fierce winds catch that iron vapour and sweep it around toward the night side, where the air, though still hotter than any furnace on Earth, is nearly 1,000 degrees cooler than the brutal day. And in that cooling, the iron does what cooling vapour has always done, everywhere, on every world. It gathers itself into droplets, it condenses, and somewhere along that endless border between the bright and the dark, on a world hundreds of light years away, it begins, very softly and without any sound that could ever reach us, to rain liquid iron from the sky, a quiet, glittering metal rain, falling forever into the dark. Hold that single image in the dark a moment longer, turned over gently like a smooth, warm stone in the hand. A rain of molten metal drifting down through the warm night air of a planet, droplets of liquid iron where on Earth there would be drops of soft water, and iron is only the beginning of it. On some of these worlds, in the right narrow range of heat, the vapour that cools and condenses could be the very makings of glass, falling as glassy beads. On others, streaks of liquid rock or clouds woven from minerals that here on our own world we would cut and polish and wear as jewels. The weather of the hot Jupiters is made of the things we think of as the most permanent and cold and solid: stone, metal, glass, gemstone. And out there, beside the fire, those solid things turn to vapour and gather into cloud and fall like a summer rain. The unmeltable, melted. The immovable, set adrift on the wind. These worlds almost certainly did not begin where they are now. A giant planet cannot easily form so close to a star, for the heat there is too great and the raw material spread too thin. The very place where a hot Jupiter now circles is the last place in the system a hot Jupiter could ever have been built. From this single, stubborn fact, astronomers were driven to an extraordinary conclusion. These giants must have formed far out, in the cold and quiet outer reaches where Jupiter and Saturn took shape in our own system, gathering their great mass slowly from ice and gas and dust in the deep chill of the dark. And then, over long stretches of time, they journeyed inward. They migrated. They drifted starward across enormous distances, spiralling closer and closer with each passing age, until at last they came to rest in the searing orbits where we find them today, like travellers who set out from a far cold country and settled, in the end, beside a fire. That single idea that a planet can wander from its birthplace changed nearly everything. Before the hot Jupiters were found, the planets had been imagined as fixed in their places, each one born exactly where it would forever remain, the whole arrangement settled and serene and final from the very start. The discovery of giants pressed hard against their stars made that calm old picture impossible to keep. Worlds, it turned out, can move. A planetary system is not a finished painting hung once upon a wall, but a slow and living dance, its members drifting inward and outward across millions and billions of years, trading places, reshaping the whole design as they go. The hot Jupiters were the first clear sign that the heavens are not nearly as still as they look from a quiet night lawn, and that even the great and ponderous giants are, in their own unhurried way, travellers across the dark. Settle that into the silence for a breath, the way a question can rest unanswered in a darkened room and still feel somehow complete. Out beyond every star you have ever named, there are worlds turning one face to a fire and one to the endless night, raining metal along the seam between, racing their winds around the dark, and far away from all of it, where the heat of those worlds is only a number and a wonder. You're growing heavier and warmer and more at ease. The journey into the strangeness of these giants has only just begun. The colours, the speeds, the inverted skies, the worlds that orbit backward, the planets being slowly swallowed by their suns. There is no need to follow any of it closely. The drifting itself is the point. How these distant worlds are even found is a wonder in its own right, since not one of them can be seen directly the way you might glimpse a single lamp glowing across a wide dark valley. The star is so overwhelmingly bright, and the planet so faint and so near to it, that no telescope can simply pick the little world out from the glare. It would be like trying to spot one firefly hovering an inch from the bulb of a searchlight, from miles and miles away, at night. So astronomers learned instead to find these worlds by their effects upon the things we can see. The earliest hot Jupiters revealed themselves entirely by the gentle tug they gave their stars, that small rhythmic to and fro in the starlight, a leaning measured not in miles but in the faintest stretching and compressing of the very colours of the light itself. The planet was never once seen, only its pull was felt, written delicately in the slow trembling of a faraway sun. The delicacy of that measurement is almost beyond believing once you pause on it. A hot Jupiter, heavy as it is, tugs its star back and forth by only a small amount, and the wobble astronomers must catch in the starlight corresponds to the star creeping toward us, and away again at no more than the pace of a person walking, or sometimes a gentle stroll, across a gap of light years. They detect that whisper of motion by spreading the starlight into its finest colours and watching the whole pattern slide by a hair, first one way and then the other, in time with the planet's orbit. To sense a giant sun shifting at walking speed, from trillions of miles off by the faint sliding of its colours, is among the most exquisite measurements people have ever learned to make, and it was the very first key that unlocked these worlds. A second way of finding them is even more delicate and even more beautiful, and it leans entirely on a lucky alignment across the void. If a planet's orbit happens to lie nearly edge-on as seen from here, then once each short year of that little world, the planet passes directly between its star and our waiting telescopes, and the star dims by the faintest fraction as the dark world crosses its glowing face. For a hot Jupiter, that crossing might last only a few hours, and it might dim the star by no more than 1 part in 100, a shadow so slight you could never catch it with the unaided eye, nor even notice it without the most sensitive instruments. Yet that tiny, perfectly regular wink, repeating every few days with the punctuality of a great clock, is the silhouette of an entire planet sliding across the light of its sun. And from the exact depth of that wink, astronomers can read the true size of the world that cast it. The first such crossing world ever caught is worth remembering by name for the doors it opened. It is a hot Jupiter circling a star catalogued as HD 209458, found at the close of the 1990s to be dimming its star ever so slightly every 3.5 days, the very first planet anywhere ever seen to transit, to pass squarely in front of its sun as viewed from Earth. That single discovery transformed these worlds from invisible tugs into solid, measurable globes with real diameters. And it was at this same world, soon after, that starlight was first ever seen filtering through an alien atmosphere, revealing the sodium hidden in its air, and here too that a planet's atmosphere was first ever caught quietly escaping into space. One unassuming giant crossing one ordinary star became the place where the study of distant atmospheres was born. The colours hidden within starlight tell their own quiet stories, perhaps the most intimate of all. When the light of a star passes through the thin upper air of a transiting hot Jupiter on its long way to us, the gases in that air drink certain precise colours out of the beam and leave their fingerprints behind in the missing wavelengths. By spreading the gathered starlight into a spectrum, a rainbow combed out into its very finest threads, astronomers can read which elements ride in the planet's distant sky. Sodium glowing faintly here, water vapour announcing itself there, the metallic signatures of iron and titanium written as narrow dark lines across the colours. A planet many trillions of miles away, never once seen as anything more than a shadow crossing a star, gives up the secret recipe of its entire atmosphere through nothing but the colours quietly stolen from a single passing ray of light. There is a world out there hotter than some of the actual stars scattered across the night sky, and its name is KELT9b. Its dayside blazes at something close to 4,300 degrees, a temperature that rivals a small cool star, and it stands, as far as anyone has yet found, as the hottest planet in the known universe. It is so fiercely and so thoroughly heated that the very hydrogen of its atmosphere is torn apart. The paired atoms of hydrogen gas ripped asunder into single lonely atoms by the sheer violence of the warmth, only to drift around to the cooler night side and there join together again, before the cycle begins once more. It is a planet whose air is endlessly broken and remade as it turns, breathing apart and back together for eternity. To watch it from a safe great distance would be to see a world glowing nearly white hot, brighter than seems possible for anything that is not itself a sun. The star that pours all of that heat onto KELT9b is no ordinary mild yellow sun like ours. It is a large and brilliant blue-white star, far hotter and far more luminous than our own, the kind of star that burns hard and bright and lives only a short while by cosmic measure. The planet circles it in a day and a half, skimming endlessly through a flood of radiance fierce enough to make its own dayside outshine the night faces of countless other stars. Worlds like this one sit at the very boundary of what we even mean by the word planet, so hot and so drenched in light that the old clean line between a small dim star and a great hot world grows thin and blurred and uncertain. And yet a world it remains, a giant of gas, surely born somewhere far cooler, drawn at last into a furnace it could never have survived being born inside, now glowing in borrowed and self-made fire at the edge of stardom. There is in fact an upper limit to how heavy a giant can grow before it stops being a planet at all, and becomes something else. Pile on enough mass, somewhere above a dozen times the weight of Jupiter, and the pressure deep inside grows fierce enough to kindle a faint, brief nuclear glow of its own, and the object crosses over into the realm of what astronomers call a brown dwarf, a kind of failed star too light ever to truly shine. A few close-orbiting giants sit right at that hazy boundary, heavy enough to leave one wondering which side of the line they fall on. The whole family of these worlds, then, is bounded above by a soft frontier where planets end and stars begin to stir, and the hot Jupiters live their lives just below it, giants that grew large, but never quite large enough to light. The night sides of these worlds are their own deep mystery, hidden faces no ray of starlight has ever once touched. While the day glows like a struck ember, the far hemisphere lies in a darkness that has never known a single dawn, cooler by hundreds or even 1,000 degrees, lit only by the dull warmth ferried over on the great winds and the faint red glow of its own slowly leaking heat. There, in that perpetual unbroken night, the vaporized metals carried from the day side finally cool and gather and condense into clouds. There, on the dark face, the iron rain falls. The night side of a hot Jupiter is the place where all the fierce chemistry of the burning day at last comes to rest and settle. A vast, warm, sunless country, where the sky quietly weeps the very metals that the day side boiled into the air, an endless cloudy midnight that no morning will ever break. The seam between those two halves of the world, the ring of everlasting twilight, has a name of its own among astronomers, the Terminator, and it may be the most temperate place on the entire planet. Step in your imagination to that narrow band where the endless day meets the endless night, and the savage heat of the eternal noon and the deep cold of the eternal dark blend just there, into something almost livable, almost in between. Along that thin glowing edge, drawn like a single bright thread all the way around the globe, the temperature shifts from one terrible extreme to the other, across a span you could never actually travel, since the planet never turns to carry any point from light into dark or back again. It is a sunset that never quite finishes, and a sunrise that never quite arrives, held frozen forever as one unmoving ribbon of dusk, the calmest seam on the fiercest of worlds. Even that one twilight ring is not the same all the way around, for the great winds break its symmetry. Picture the seam split into two long edges, a morning edge, where the gas is sweeping in fresh and cool off the night side and only beginning to be warmed, and an evening edge, where the gas arrives already heated through from its long crossing of the blazing day. The two edges of the very same Terminator can differ markedly in their temperature and in the clouds that hang there. One side clearer, one side hazed, one a touch warmer than the other, simply because of which way the wind is blowing as it passes. Astronomers have begun to tease apart these two halves of the ring in the light of a crossing planet, reading a morning and an evening into a world that has neither, only an endless circling wind. How fast these worlds spin around their suns is nearly beyond the mind's grasp, and worth pausing over in the dark. A hot Jupiter circling its star in 3 days is travelling along its orbit at well over 100 miles in every single second. Some of the very closest race at more than 200 miles a second, 250,000 miles an hour and beyond. A giant planet flung around its star so swiftly that it crosses a span wider than our entire sun in a matter of mere minutes. Our own Earth, by comparison, ambles along its yearly path at a leisurely 18 miles a second, and even Mercury, our quickest world, manages only 30. And yet, seen from far enough away, all that frantic motion looks like nothing at all. A tiny bright bead creeping slowly around its star, the sheer violence of its speed dissolved entirely by distance into the most unhurried of circles. The tides these worlds endure are forces of a kind the Earth has never even approached. Our own moon raises tides in our seas, gentle swellings of the ocean only a few feet high, because the moon pulls a touch harder on the near side of the Earth than on the far side, and that small difference tugs the water into a bulge. Now press a giant planet right up against its star, and that difference in pull from one side of the world to the other becomes immense, overwhelming. The star stretches the whole hot Jupiter, drawing it ever so slightly out of round into the shape of an egg, the near face bulging toward the fire and the far face bulging away from it. The entire planet is squeezed and pulled and kneaded by the nearness of its sun, shaped by raw gravity into something that is not quite a sphere, and held there in a permanent and utterly silent strain for as long as it circles. And the pull runs both ways, for a close enough giant tugs back upon its star and raises tides in the star itself. A massive hot Jupiter, swinging near, can lift a slight bulge in the glowing surface of its sun, drawing the whole star a little out of round into a faint egg shape that turns to follow the planet around. As the world circles, that raised bulge swings with it, and the star's brightness rises and falls by the smallest measurable amount, twice each orbit, as we see now the wider side of the swollen star and now the narrower end. Astronomers can actually detect that tiny rhythmic flexing of a whole star, stirred by the gravity of its planet, a giant gently kneading the sun it orbits, the way the sun kneads it, the two locked in a slow mutual squeeze across the dark. That endless squeezing can warm a whole world from the inside out, much the way a length of wire bent back and forth quickly grows warm between your fingers. As the star's relentless pull flexes the planet, stretching it, releasing it, stretching it again with every slight wobble in its orbit. Some of that ceaseless flexing turns to heat deep within the body of the world, adding a quiet inner furnace to the blaze pouring in from outside. It is one of the answers astronomers reach for when they try to explain why so many of these worlds are puffed so much larger than their mass alone should allow. Not only the fierce heat of the star upon their faces, but a slow tidal warmth working outward from the very core, swelling the giant from beneath even as the sunlight swells it from above. A world heated patiently from two directions at once, and bloated gently by both. Some hot Jupiters are slowly losing themselves to the very stars that warm them. The outer air of a world heated past all reason can grow so hot, so agitated, that the planet's own gravity can no longer keep its grip on it. The lightest gases at the very top of the atmosphere boil away into space, streaming off the sunlit face and trailing out behind the planet in a long, faint plume, so that the whole world comes to wear a comet's tail, drawn out by the heat and the pressure of the starlight. A few of these worlds are evaporating grain by grain, atom by atom, across the long ages, shedding their atmospheres into the dark like steam off a cooling cup. Even a giant, even a world the size of Jupiter, can be slowly worn thin by standing too long, too close, beside an open flame. Nothing near such a fire is ever entirely safe from it. One particular kind of escaping gas has let astronomers actually see those fleeing atmospheres trailing away. Helium, the second lightest element in all the universe, glows in a precise shade of infrared light when it is heated and lifted high, and on certain hot Jupiters that helium has been caught streaming off the planet in an enormous tail, swept back by the pressure of the starlight like the tail of a comet leaning always away from the sun. The tail can stretch for many times the width of the planet itself, a great pale streamer of escaping gas pointing forever into the dark behind the world. To detect it, astronomers simply watch for that one telltale colour of helium to deepen and shift as the planet crosses its star. And in that single deepening line, they read the slow unravelling of a whole distant atmosphere into space, There may once have been worlds that did not survive that nearness at all, and their ghosts may still be out there. If a giant planet can lose its atmosphere to a fierce enough star, then somewhere in the long history of the galaxy there were surely hot Jupiters that wandered in too close, or were born beside stars too hot to bear, and were stripped clean down to their dense inner cores. The entire envelope of gas boiled away into nothing, leaving only the small, heavy heart that once lay buried at the very centre of the giant. Astronomers have found a few strange, dense, oddly heavy worlds that may be exactly that. The bared and naked remnants of giants that lost everything else they had to the star. The galaxy, it seems, keeps the bones of its planets as faithfully as it keeps their living forms, scattered quietly among the stars. The winds that wrap these worlds do not blow at random or in gusts. They organise themselves over time into vast and steady currents that circle the entire planet. On a tidally locked hot Jupiter, the heat always arrives on the same unchanging face, and so the air always flows in much the same direction, settling at last into a great banded pattern of jet streams streaming endlessly around the globe. The strongest of these is an equatorial river of wind that races eastward around the planet's broad middle, and it does something curious and revealing along the way. It shoves the single hottest point of the entire world off-centre, carrying the peak of the heat a little past the spot directly beneath the star, downwind of high noon, the way a warm afternoon stays hottest a few hours after midday, rather than exactly at 12. The hottest place on the planet is not quite under the sun, but just to the leeward of it. That small displacement of the heat is something astronomers can actually detect from light years away, and the cleverness of how they do it is its own quiet marvel. As a hot Jupiter circles its star, it gradually shows us its different faces in turn. A little more of the blazing day side, then a little more of the dark night side, and the total glow we receive from that corner of the sky rises and falls smoothly with that slow turning. By watching exactly when that glow reaches its peak, astronomers can tell that the brightest part of the planet is not pointed straight at its star, but is shifted noticeably to one side. And from that timing alone, from the precise moment of a faint swelling in the infrared light, they can map the prevailing winds of a world they will never visit and could never survive. The prevailing breeze of a world unthinkably far off, read in the rhythm of its glow, like a forecast no one will ever stand beneath. Picture the visible surface of one of these worlds, banded and striped, wrapped round in ribbons of cloud. The great giant of our own sky is famous for its belts and zones, those parallel bands of cream and tawny brown and rust drawn around it by the steady churning of its winds, the stripes you can pick out through even a modest backyard telescope. The hot Jupiters too are wrapped in bands by the powerful currents of their air, but their stripes are forged in fire rather than in cold, clouds not of pale ammonia ice, as on our own distant frigid Jupiter, but of vaporized rock and glowing metal and shimmering mineral, faintly aglow with their own heat, smeared out into long ribbons by winds that never once pause for breath. A striped giant much like the one you may have admired on a clear night, but lit softly from within and woven entirely from the rising breath of molten stone. The clouds of a hot Jupiter would be like nothing you have ever stood quietly beneath on a grey afternoon. On the cooler reaches of these worlds, where the temperature happens to fall into just the right narrow band, minerals condense straight out of the vaporized air and gather into high hazes and thick decks of cloud. Clouds of silicate, which is the very stuff of common sand and window glass. Clouds threaded through with droplets of iron, and in some careful models, clouds that glitter with corundum, the same hard mineral that, when it grows slowly and pure in the earth, becomes a ruby or a sapphire. Imagine a sky overcast, not with grey water vapour, but with a fine, suspended dust of gemstone and metal and glass, catching the deep red light of the dayside and scattering it softly, drifting on winds hot enough to melt lead. The overcast of another world, woven entirely from the jewels of our own. There is good reason to believe that on at least one of these planets, the sky may hold a kind of rainbow. On a world wrapped in just the right uniform clouds, the light of the star scattering back off a deck of perfectly round, perfectly even droplets can paint a soft circular halo of colour into the air, a phenomenon seen sometimes in our own skies from the window of an aircraft, where it is called a glory. A small ring of rainbow light cast upon the cloud below, often circling the plane's own tiny shadow. Astronomers studying one particular hot Jupiter found a faint hint of exactly this, a soft repeating glow that may well be starlight scattering off remarkably uniform clouds into a coloured ring hung in the burning air. A rainbow of a sort, a glory cast not by sunlight on rain, but by a distant star on clouds of glass, hundreds of light years from any eye that might admire it. Many of these giants circle stars that are not alone, but are part of a bound pair, two suns held together in a slow, mutual embrace. More than half of all the stars in the galaxy are not solitary like our own sun, but live in twos or threes, locked in orbit around one another, and plenty of hot Jupiters belong to just such crowded families. On a world like that, were you somehow able to stand upon the eternal dayside and look up without being scorched away, you might see not one sun in the sky, but two, a near and brilliant primary star filling much of the heavens, and far off behind it a second, smaller star, a single, bright, unblinking point that never sets and never rises, slowly circling the first across the span of years and centuries. Two suns hanging in one sky, over a single world that turns its face toward neither, for it is forever locked to only the nearer of its two fires. The orbits of some hot Jupiters are not the tidy circles you might first expect, but long-stretched ovals that carry the world swinging in near the star and then far away from it again, over and over. A planet on such a path lives through wild extremes that shift across its very short year. Drawn in close to the fire, it is scorched and visibly swollen by the gathering heat. Flung back out to the far end of its long loop, it cools a little in the relative dark before falling helplessly back toward the blaze once more. These stretched, eccentric orbits are precious clues to the violent histories of the worlds that ride them, strong signs that the planet may have arrived at its blazing home not by any gentle inward drift, but by a far fiercer path, slung inward long ago by the heavy gravity of some other giant in a gravitational quarrel that has long since gone silent. That fiercer path has a name, and a strange grandeur clings to it. Some hot Jupiters, astronomers have come to believe, were thrown violently inward when another massive planet passed too close and flung them onto a wildly stretched orbit, a long thin ellipse that carried them skimming dangerously past the star at one end and far out into the cold black at the other. Over the slow grind of time, the star's tides at each close passage would steal away a little of that orbit's energy, draining it pass by pass, pulling the far end gradually inward, until the long-stretched oval at last rounded itself down into the tight circle of a settled hot Jupiter. A world hurled inward by a sibling's careless pull, and then tamed across millions of slow years by the steady invisible hand of the tides. A story that begins in upheaval and violence and ends improbably in perfect stillness. Some of these planets do not even circle their stars in the same direction the rest of the system turns. In our own orderly solar system, every planet orbits in very nearly the same flat plane, and all in the same direction the sun itself spins, the whole arrangement turning together one way like a great and dignified wheel. But some hot Jupiters orbit steeply tilted out of that plane, leaning their paths at sharp angles, and a few orbit backward altogether, running directly against the spin of their own star, circling east as it were, while the star beneath them turns to the west. Such a backward, tilted, contrary path could only have come from a violent and chaotic past, a planet flung onto a rogue orbit by some long ago close encounter, now forever out of step with the very star that birthed it, going its own stubborn way around the fire while everything else turns the other. How astronomers can possibly know the tilt of an orbit they cannot see is a small triumph of patient ingenuity. A star, like everything else, spins, and so one edge of its glowing disk is always turning toward us while the other edge turns away, and that motion subtly shifts the colours of the light from each side. When a transiting hot Jupiter crosses the face of its star, it covers first one edge and then the other, briefly hiding the approaching limb, then the receding one, and the star's measured colour wobbles in a telltale little dance as it does. From the precise shape of that wobble during a single crossing, astronomers can read whether the planet swept across the star squarely, in line with its spin, or slantwise across it, against the grain. And so they map the true tilt of an orbit, the alignment or the defiance of a world, written in the passing shadow's path across a turning sun. The amount of starlight that falls upon one of these worlds is genuinely difficult to hold steady in the mind. A hot Jupiter circling its star at a small fraction of even Mercury's distance can receive thousands of times as much light and heat upon each patch of its surface as the Earth ever receives from our own sun. Stand on a beach at high noon on a cloudless day in deep summer and feel the full warmth of the sunlight pressing on your skin. Now multiply that warmth by thousands and pour it down without pause, without night, without season, without the smallest relief onto one single unmoving face of a planet forever. That is the daylight of a hot Jupiter, a flood of radiance so vast and so unrelenting that it remakes the chemistry of the air, tears molecules to pieces, lifts whole metals into vapour, and sets the entire world aglow with light of its own making. Across the long and growing catalogue of these worlds, astronomers have begun to sort them by their heat, and a clear and rather lovely pattern has slowly emerged from the data. The cooler hot Jupiters, where the temperature lingers below the threshold at which metals turn to vapour, can keep ordinary clouds and ordinary chemistry, their day sides relatively dim and dark and subdued. But cross above that one critical line into the ultra-hot range, and everything changes all at once. The metals boil up into the air, the molecules shatter into their atoms, and the dayside flares into sudden brilliance. There is a temperature, somewhere near 2000 degrees, that behaves almost exactly like a doorway, and a hot Jupiter sitting on one side of it lives an utterly different life from one sitting on the other. The very same planet, shifted just a few hundred degrees warmer or cooler, would be two entirely separate kinds of world. On the very hottest of these worlds, the dayside glows so brightly with its own light that astronomers can watch the planet vanish and reappear with no transit involved at all. As an ultra-hot Jupiter swings around behind its star, its glowing dayside is hidden from view, and the total light from that corner of the sky drops by a small but perfectly measurable amount, then climbs smoothly back up again as the planet emerges from behind the star and turns its bright face our way once more. That little dimming, the moment when the planet's own fierce glow is briefly eclipsed by the star, lets astronomers measure precisely how brightly the dayside truly shines, and so exactly how hot it must be. A world detected not by the shadow it casts upon its star, but by the radiance it pours out on its own. A planet bright enough to be genuinely missed when the star happens to step in front of it. How young this whole field of knowledge truly is can be hard to believe. Before 1995, not one single planet was known anywhere beyond our own sun's small family. The great question of whether other stars carried worlds at all was an ancient one, debated by philosophers and astronomers for thousands of years, with no possible way to ever settle it. Then came one faintly wobbling star and one impossible giant pressed against it, and within just a few short decades the count of known worlds had climbed past 1, past 100, past 1,000, and onward into the many thousands where it stands today. And the hot Jupiters led the entire way, because they were by far the easiest to find, the loudest, the most insistent, the most impossible to overlook, tugging hardest of all on their stars and dimming them deepest as they crossed. The strangest worlds in the sky, fittingly, were the very first ones we managed to hear. That they were found first is partly a quiet trick of the method, a thing worth holding gently in mind so as not to be misled by it. Hot Jupiters are not, in truth, the most common kind of planet out there. They are in fact rather rare, circling perhaps only one star in 100 or so. But they are by far the most detectable, massive enough to wobble a whole star strongly, large enough to block a generous slice of its light when they cross, and quick enough to repeat their entire signal every few days, so that a watcher need only wait a week to catch the proof come round again. The galaxy's quieter, smaller, more modest worlds were there all along, waiting unseen in the dark, but the giants near the flame announced themselves first, loudly and at once, simply by being utterly impossible to ignore. The early discovery of these worlds sent the theorists scrambling, and there is something warming in imagining that sudden flurry of rethinking. For decades, the careful models of how planets form had predicted only neat, orderly, well-behaved systems. Small rocky worlds tucked near the star, great gas giants kept safely far away, each in its proper and permanent place. The models were elegant and widely taught, and they were wrong, or at the very least badly incomplete. The hot Jupiters arrived as a puzzle no existing theory had any room for, and they forced an entire generation of astronomers to imagine suddenly planets that move, systems that rearrange themselves over time, giants that wander inward across the dark. A single unexpected world cracked open a settled and confident science, and a far richer and stranger story came pouring in through the gap it left behind. The sound of these worlds, if you could somehow stand near enough to hear it, would be a roar that never once ends. The winds that race around a hot Jupiter at a pace no hurricane could ever approach, outrunning the very sound moving through their own dense air, would tear through that hot, thick atmosphere in a ceaseless planet-wide thunder, a howl with no pause for night or season or rest. And yet across the vast silence of space, not the faintest whisper of all that fury ever reaches us. The whole violent symphony plays on inside a vacuum that carries no sound at all, so that a world screaming endlessly with wind appears to us, from here, as the most perfectly silent thing imaginable. A still, small, bright point of light, drifting soundlessly around its star. All that thunder, all that ceaseless roaring, and across the dark between us, only the deepest silence. The colours of a hot Jupiter sky would shift dramatically as you imagined yourself moving across its single endless day. Near the searing point directly beneath the star, where the heat gathers to its greatest, the air glows fierce and white and overwhelming, almost too bright to bear. Move outward, toward the distant twilight edge, and the glare gradually softens, the glow deepening from white through orange and into a sullen ember. Red as the temperature falls and falls, the heavy metals beginning to gather into haze. Cross over the terminator into the night side and the brightness fades further still, down to a dull cherry red afterglow, and then at last darkness. The sky lit only by the planet's own slowly cooling warmth and the cold, distant, unwavering points of other stars. A single world holding every shade at once, from blinding white through every warm colour down to embered dark, all of it fixed in unmoving bands that never shift, because the planet never turns. There is a deep beauty in how thoroughly these planets break the old, simple, comfortable rule that near the star always means small and rocky. In our own system, the inner worlds are stony and modest in size, Mercury, Venus, Earth, and Mars, while the great gas giants keep dutifully to the cold outskirts far from the warmth. For a long while it seemed very nearly a law of nature. The hot Jupiters quietly revealed that it was never a law at all, only a local habit, true of our own particular family, but not at all of the wider galaxy. Out there, beyond our small corner, giants crowd the innermost orbits of countless stars, and the tidy, ladder-like arrangement of our own familiar sky is shown to be merely one possibility among a great many, neither the rule nor the standard nor the norm, but simply the particular shape that our own small neighbourhood happened, by chance, to settle into. A year that lasts a single day is a thing worth resting the mind upon for a while. On these worlds, the entire journey all the way around the star, the full circuit that here on Earth we call a year, and slowly fill with all 4 turning seasons, is finished and begun again in less time than passes between 2 of your meals. There can be no spring on a hot Jupiter, no slow ripening of warm months into cold and back, no harvest, no thaw. The orbit is far too swift and the planet far too tightly locked for anything we would call a season to mean a thing. The day side is always high summer, hotter than any summer the Earth has ever known. The night side is always its own fixed and starless winter, and the year itself simply flickers past again and again and again, faster than the mind can quite accept. A steady blur of orbits in which a single one of our Earth weeks might hold a dozen of the planet's complete and dizzying revolutions around its sun. Some of these worlds wander startlingly, almost unbelievably close to their stars, closer than seems like it ought to be survivable for anything at all. There are hot Jupiters orbiting at only a few stellar radii from the very surface of their suns, so near that the star would fill a vast swathe of the planet's entire sky, an enormous unmoving wall of fire hanging fixed overhead, taking up far, far more of the heavens than our own small distant sun ever fills for us. From the day side of such a world, the star would not be a tidy bright disk you could blot out with a raised thumbnail at arm's length. It would be a colossal glowing dome spread across the whole sky, so large and so impossibly close that there would seem to be no sky left at all beyond it, only fire, filling the world from one burning horizon clear across to the other. The tightness of these orbits is easiest to feel by setting them against our own sun. Our star is a vast thing, well over 800,000 miles across, and yet the very closest hot Jupiters circle their own stars at distances so small that the entire loop of their orbit, the full circle of their year, would fit comfortably within a sphere not much larger than a star like ours. Imagine a planet whose whole orbit you could tuck inside the body of the Sun, with room to spare. Its complete journey around its star spanning less than the width of our own daytime star in the sky. Where the Earth swings around the Sun across 93 million miles, some of these giants complete their circuit within a few million, or even less, threading a tight bright ring around a fire that fills half their heaven. The sheer abundance implied by all these discoveries carries a quiet and almost tender meaning. If hot Jupiters, rare as they genuinely are, still turn up around as many as 1 star in 100, and if they are merely the easiest of many, many kinds of world to detect, then planets in general must be extraordinarily, almost unimaginably common. The galaxy must be filled to its brim with worlds, more worlds than there are stars in the sky, circling very nearly every single point of light you have ever seen on a clear night. The hot Jupiters were the very first hint of a cosmos absolutely crowded with planets, the opening of a door into what is now settled and certain knowledge, that worlds are not rare and precious jewels scattered thinly across an empty dark, but the ordinary everyday furniture of the heavens, present almost everywhere a star quietly burns. Drift now toward the finer details of these worlds, toward the small and precise astonishments that decades of patient study have slowly drawn out of the starlight. The atmospheres of the very hottest Jupiters, it turns out, can carry a structure entirely upside down from what feels natural and right. Here on Earth, the higher you climb, the colder the air becomes, until the peaks of even the tallest tropical mountains wear caps of snow that never melt. But on an ultra-hot Jupiter, certain metals suspended high in the atmosphere drink in so much of the star's radiation that they heat the upper air far more than the lower, so that the temperature actually rises as you ascend rather than falling. The sky grows hotter overhead, not cooler, a thermal inversion, astronomers call it. A strange world where to climb upward toward the cold of space is, against all instinct, to climb toward ever greater heat. The element titanium, which here on Earth we prize and machine for its great strength in solid form, plays a surprising and outsized part in the skies of these distant worlds. In the hot atmospheres of certain Jupiters, titanium binds together with oxygen into a vapour, titanium oxide, that turns out to be an extraordinarily powerful absorber of starlight, soaking up radiation high in the air and warming those upper layers into exactly one of those inverted top-heavy temperature structures. A metal that we mine from the ground and forge with great effort and trust to hold the wings of an aircraft together, floating instead as a faint trace of gas in an alien sky, quietly governing the entire climate of a planet by deciding, molecule by molecule, just where its falling starlight will be turned into heat. The strong, cool grey metal of the machine shop transformed into the weathermaker of a far-off world. Sodium, the soft silvery metal that colours a street lamp orange and salts the whole of the sea, was among the very first substances ever detected in the air of another planet anywhere. When astronomers carefully spread the light of a transiting hot Jupiter into its full spectrum, they found, written there in two narrow and unmistakable dark lines, the clear signature of sodium vapour riding high in the planet's sky, the very same element that flavours the food on your table and glows warm orange in the lamps along a quiet night road, identified now across hundreds of light-years of empty space in the atmosphere of a world no human hand will ever come close to touching. It is the deeply familiar made suddenly strange and vast, a simple pinch of common salt, glowing softly in the burning air of a giant beside a distant fire. Water rides in the skies of a great many of these worlds as well, though never as anything you would recognise from a kitchen tap or a falling rain. On a hot Jupiter, the temperatures run far too high for liquid water or for ice. Any water that exists there at all can exist only as a searing vapour, a steam hotter than the inside of any oven, mingled invisibly with the hydrogen and the vaporised metals of the air. And yet it is genuinely water, all the same. The very same molecule that fills your glass on the nightstand and falls as soft rain at home and freezes into the frost on a winter window. Its faint fingerprint found again and again in the light passing through these alien atmospheres. The most ordinary substance of all life, present even out there, woven through the burning air of worlds where it could never once pool, or freeze, or quench a single living thirst. The hottest of these worlds glow most brightly in colours the human eye can never see, and learning to read those invisible colours is precisely how their deepest secrets have been coaxed out into the open. Much of a hot Jupiter's own light pours out not as visible glow at all, but as infrared. The warm, low radiation you feel pressing on your face as heat from a fire, even with your eyes gently closed against the light. Telescopes built especially to see in that warm infrared band can map the temperature across a planet's whole face from light years off, charting where it burns hottest and where it cools toward the dark, even watching the heat itself slide slowly from the day side toward the night on the back of the great winds. The full portrait of a distant world's weather, painted entirely in a light too red and too warm for human eyes, and gathered across the enormous gulf of space. Astronomers have even begun to take the temperature of these worlds all the way around their globes, mapping how evenly or unevenly the heat is spread from the single blazing point to the deepest reaches of the night. On some hot Jupiters, the winds prove so remarkably efficient at carrying warmth around the planet that the night side stays nearly as hot as the day, the heat smeared smoothly and generously all the way around by the racing air. On others, the wind simply cannot keep up with the relentless arrival of new heat, and the night side falls far, far behind, frigid and dark while the day side blazes on, the two faces of one world separated by well over 1,000 degrees. The efficiency of a planet's winds, read precisely in the evenness of its glow, with each distant world quietly telling us, in light, just how well or how poorly it manages to share its heat. A particular tenderness attaches to the planet 51 Pegasi b, the very first of these worlds ever found, now studied far more closely than was ever possible back in 1995. It circles its sun-like star once every 4 days, At a distance only about a 20th of the gap between our own Earth and Sun, its day side warmed past 1,000 degrees, a giant near the full mass of Jupiter that single-handedly opened the entire age of exoplanets. Decades after that first faint detection, astronomers managed at last to catch the planet's own light directly, teasing the faint reflected and emitted glow of the world apart from the overwhelming blaze of its parent star, a feat thought nearly impossible at the start. And so the planet that first opened the door became, fittingly, one of the very first whose true and separate face was ever, however faintly, actually seen. The star around which that first world quietly orbits has a dignity all its own, worth a moment's notice. It is called 51 Pegasi, an ordinary star much like our own Sun, though a little older and a little brighter, lying about 50 light-years away from us in the direction of the constellation Pegasus, the great winged horse of the old star maps. On a clear and truly dark night, far from the glow of any city, it is just barely visible to the unaided human eye as the very faintest of points. A real star you could actually find and look upon, if you knew exactly where among its neighbours to search, around which turns the first planet ever discovered beyond our own Sun. The light leaving that star tonight, this very evening, will not arrive at the Earth until half a century has passed, long into a future none of us can quite picture. The way these worlds are named follows a quiet and orderly logic that is pleasant to turn over in the mind. A planet simply takes the name of its star, with a small letter added on at the end. The letter B for the first planet found around it, then C, then D, and onward through the alphabet for any further worlds, in the strict order of their discovery rather than their distance. The star itself holds the letter A, though that first letter is almost never spoken aloud, and so a world like 51 Pegasi b wears its entire cosmic address openly in its name, the star it belongs to, and its exact place in the order of finding. Many thousands of worlds now carry such names, each one a star's label followed by a single trailing letter, a vast and ever-growing roll of distant planets, drawn up in the plain and humble alphabet of human discovery. A few of these worlds, though, have been granted true names as well, chosen by people the world over. To mark the wonder of them, the keepers of astronomical names have held public votes, inviting anyone who wished to propose a name for certain famous planets and their stars. And so that very first hot Jupiter, the giant around 51 Pegasi, was given the name Dimidium, drawn from a Latin word for half, in honour of its being near half the mass of Jupiter, while in its earliest days it had carried, unofficially and affectionately, the name of a hero out of old Greek myth. There is something warming in the thought that a world hidden 50 light-years away, found only by a wobble, was named in part by ordinary people who simply liked the idea of it, reaching out to christen a planet none of them would ever see. Many of these worlds carry the names of the great surveys that first caught them, like a kind of inherited family name. A large number of hot Jupiters were found not one at a time but by sweeping projects that watched many thousands of stars all at once, night after night, simply waiting for the tiny regular dimming of a transit to appear somewhere in the crowd. The clusters of capital letters that begin so many of their names, the wasp, the celt, the hat, the tress that open the names of so many hot Jupiters, are the initials of those very telescopes and projects that first caught the planets crossing. They were often small and modest instruments, some scarcely grander than a good camera, that simply watched the whole wide sky tirelessly, for years on end, for the faint repeated wink of a passing world. Humble little machines, finding giants around faraway suns. There is a real wonder in just how small the instruments often were that found these enormous worlds. Some of the most productive planet hunting surveys in history used arrays of camera lenses scarcely bigger than the ones in an ordinary photographer's bag, set out under the open sky to watch broad swathes of stars for the faint, repeated telltale dimming that betrays a transiting planet. A giant world larger than Jupiter itself, hundreds of light-years away across the dark, first noticed by a small cluster of modest lenses no grander than a hobbyist's kit, found simply because someone, somewhere, thought to watch closely enough and long enough for the tiny shadow to come around once again. Great discoveries do not always demand great and costly machines. Sometimes they ask only for steady eyes and the willingness to keep watching the same quiet sky. Then came the space telescopes, lifted clear above the blurring, shimmering ocean of our atmosphere, and the count of these worlds truly soared. One observatory in particular stared without once blinking at a single chosen patch of sky for years on end, watching more than 150,000 stars all at the same time, waiting for any one of them, ever, to wink. And it found thousands upon thousands of planets, hot Jupiters scattered among them, entirely by the faint shadows of their crossings. Up above the restless atmosphere, where the starlight arrives steady and clean, and the night never once clouds over or wavers, the dimming of a star by a passing world can be measured with a delicacy that is simply impossible from the ground below. Whole new worlds by the thousand drawn quietly out of the long unwavering stare of a single telescope, hanging in the dark high above the sky. The transits of these worlds keep time with an almost impossible precision. They tick like clocks you could set your whole life by. A hot Jupiter crossing the face of its star does so on a schedule so perfectly regular that astronomers can predict the exact moment of the next crossing to within mere seconds, years and years in advance, and then watch it arrive precisely on time. The planet has been faithfully circling that star for ages beyond counting, swinging round every few days with the steady reliability of a great slow pendulum, and that ancient rhythm holds so true that a single missed beat, a transit arriving even slightly early or slightly late, would itself be genuine news, a quiet sign of some other unseen world tugging gently on the timing from out of the dark. The most dependable clocks in the entire sky are these distant giants, faithfully ticking off their swift short years against the steady light of their suns. The sheer distances involved are worth resting the mind upon gently, without ever trying to truly grasp the numbers. The very nearest hot Jupiters lie tens of light years away from us. A great many lie hundreds, some lie thousands, out toward the far reaches of what our instruments can yet sense. The very light by which astronomers now study them left those distant worlds long, long ago, in some cases before the first cities of the earth were ever raised from mud and stone, and then crossed all that empty intervening dark, year upon silent year, to arrive at last in a telescope's patiently waiting glass. When you read of the iron rain falling on a world some hundreds of light years off, you are in truth reading the ancient news of a place so impossibly distant that the very rain described to you fell while the great stone cathedrals of Europe were still being slowly raised, and is only now in its faint signature reaching us. The dayside glow of a hot Jupiter, were you somehow able to see it with your own eyes from a safe distance, would be a thing of fearful beauty, held at arm's length and turned softly over in the mind. The hottest of these worlds would shine a sullen red, or a deeper smouldering orange, or in the most extreme cases a pale and dreadful white, glowing steadily across their whole sunward face like a single ember, the size of an entire planet. It would not be a cool, reflected gleam, like the borrowed silver light of our own familiar moon, but a true and direct outpouring of light born of heat, and heat alone. A giant globe radiating its own coloured fire freely into the surrounding dark, visible across the void as a faint warm point that is, in plain truth, a world resting right on the very edge of glowing like a small star of its own. The thin escaping envelopes of gas that some of these worlds are slowly losing into space form structures of surprising and unexpected grace. As a planet's heated atmosphere boils away off the sunlit face, it does not simply vanish quietly into nothing. It streams outward in great wisps and long trailing tails, shaped and sculpted by the starlight and by the star's own outflowing wind into flowing plumes, sometimes sweeping out ahead of the planet and sometimes streaming far behind it. A few hot Jupiters have been caught in the act of wearing vast clouds of escaping hydrogen, many, many times the size of the planet itself, faint enormous halos of fleeing gas, glowing softly in ultraviolet light invisible to us. A giant slowly and silently unspooling a great pale banner woven from its own escaping air, light years from any living eye that might ever watch it stream. The study of these distant atmospheres has matured into something astonishingly, almost unbelievably fine. Astronomers can now sometimes detect not merely which elements happen to ride in a hot Jupiter's air, but how those elements are actually moving through it, whether a particular metal is being swept by the great winds from the day side toward the night, whether the gas as a whole is rising or sinking, whether the entire outer atmosphere is quietly streaming away into space. From nothing more than the faint, subtle shift in the colours of the gathered light, the very air of a world hundreds of light years off can be timed and clocked, its winds measured out in miles per second, its weather read across the dark like a far-off forecast that no creature will ever need, and that everyone hearing of it may quietly wonder at. The motion of an alien wind caught in the trembling of a colour. The newest and sharpest of the great space telescopes has turned its enormous gold-coated eye toward these worlds and seen further into their air than any instrument before it. Tuned with great care to the warm infrared light where these planets glow most brightly of all, it can pick apart the atmosphere of a single hot Jupiter into a remarkably detailed list of its ingredients: water vapour and carbon dioxide, sulfur compounds, traces of metals and more, each leaving its own unmistakable mark across the spectrum of the gathered light. With every such careful reading, a distant burning world becomes a little more truly known, a little less a blank mystery, its sky-charted gas by gas and molecule by molecule from a quiet vantage point a million miles out beyond the Earth, in the cold and steady dark. A surprising kind of chemistry has been found high in the atmospheres of some of these worlds, born purely of the relentless violence of the starlight pouring down. On certain hot Jupiters, the intense radiation streaming from the star drives reactions in the upper air that actually produce hazes and soots, fine dark particles of complex carbon that drift suspended in the planet's sky and tint the light that passes through it. The very same fierce energy that tears stable molecules apart can also, in the right conditions, forge entirely new ones, knitting loose carbon together into smog-like veils hung high above the glowing surface. A planet quietly manufacturing its own haze out of raw sunlight and broken air, much the way a single-struck match sends up its own thin curling thread of smoke into a still room. There is one particular world where the winds have been clocked at a truly staggering pace, faster than nearly anything else ever measured anywhere in the heavens. On at least one hot Jupiter, the great equatorial jet stream has been gauged streaming along many kilometres in every second, a wind so impossibly swift that it would race all the way around the entire Earth in less time than an afternoon nap. The air of that world is not so much a breeze or even a gale as a permanent supersonic torrent, roaring around the planet always in one single unwavering direction, ferrying the day's gathered heat steadily toward the cold of the night in a glowing river of gas that never slows, never reverses, never stalls, and never finds so much as one passing moment of true stillness in all of its endless, tireless racing around the dark. Some of these worlds may be wrapped in high clouds that genuinely gleam, throwing their stars' light back out into space like a vast and gently curving mirror hung in the sky. While the very hottest Jupiters glow with their own deep internal heat and greedily swallow nearly all the light that strikes them, certain cooler ones, draped in high, bright, reflective decks of cloud made of mineral or of metal, throw back a notable share of the starlight that lands on them, shining partly by reflection, much as our own pale moon does in the night. A world that is somehow both a lamp and a mirror at once, glowing faintly from its own retained warmth, and gleaming as well with the cool, borrowed brightness of its nearby sun, casting a quiet double light, half its own and half the stars out across the surrounding dark. Most of these worlds, though, are not mirrors at all, but very nearly the opposite, among the darkest objects yet found anywhere in the heavens. A great many hot Jupiters reflect back almost none of the light that falls upon them, swallowing nearly the whole flood of starlight into their hazy, sooty, metal-laden air, so that if you could somehow set one beside a lump of fresh coal, the planet would be the darker of the two. Some return less than 1/10 of the light they receive, a few far less even than that, drinking in the radiance and giving almost nothing back. They are blacker than charcoal, blacker than a moonless field, and yet they still glow, faintly and ruddily, with the heat of all that swallowed light. The very sodium and other gases that ought to brighten such a world instead absorb the incoming starlight greedily, and the soots forming high in the air darken it further still, until almost nothing is thrown back at all. A world that is at once nearly the darkest object in its sky, and, in its own warm infrared, very nearly the brightest. The deep interiors of these giants are realms of pressure and heat beyond anything that has ever existed, or could exist, anywhere on Earth. Beneath the visible clouds, the gas grows steadily denser and hotter the further down you go, the hydrogen squeezed harder and harder by the immense weight of everything piled above it, until it eventually stops behaving like a gas at all and becomes instead a strange hot fluid. And deeper still, in many models, that fluid is crushed so utterly that it turns into a metal, hydrogen pressed so violently that it conducts electricity, flowing like a hidden sea of liquid silver. At the very centre of it all may rest a small, dense core of rock and ice and heavy metal, the original seed around which the entire towering giant first gathered, now buried beneath tens of thousands of miles of crushing, glowing, churning fluid. A small stone heart, wrapped in a deep ocean of luminous hydrogen. That deep, churning sea of metallic hydrogen, if it flows and circulates as the planet slowly turns, could generate a powerful magnetic field, an invisible cloak of force wrapped entirely around the world. On the hot Jupiters, this hidden magnetic field, stirred by the planet's spin and its own great inner heat, may well be far stronger than the Earth's own quiet magnetism, throwing up a vast and unseen shield that constantly wrestles with the wind and the streaming radiation pouring relentlessly off the nearby star. Where the planet's own magnetism collides with the stars, there may be enormous invisible structures of pure force, bridges and arches and loops of magnetic field linking the world to its sun, glowing faintly in radio light that astronomers have only just begun to listen carefully for. An entire architecture of the invisible, strung silently across the gap between a planet and its fire. The aurora of such a world could be a glory far beyond ordinary imagining, if only there were an eye placed there to catch and hold them. Here on Earth, our familiar northern and southern lights are kindled when charged particles from the sun pour down along the curving lines of our magnetic field and strike the thin high air near the poles, setting it gently aglow in shifting curtains of green and red and violet. Now set a giant planet right beside a fierce and close-burning star, drenched ceaselessly in a storm of stellar particles and wrapped in a magnetism perhaps far greater than our own, and the aurorae there could be vast and constant and overwhelming, great glowing crowns of cold light burning without pause at the magnetic poles, fed endlessly by the nearby fire. A planet wearing brilliant shifting rings of cold pole light at the very top and bottom of its world, even as its day side blazes white with heat. A few hot Jupiters have been found circling stars that are still very young, barely finished forming, and these are precious beyond their number. Most known giants orbit mature, settled stars billions of years old, their long migrations finished in some unrecorded past. But a handful have turned up around stars only a few million years old, infants by cosmic reckoning, still wrapped in the last traces of the swirling disk that bore them. Catching a hot Jupiter so early is like glimpsing a traveller still on the road rather than long since arrived, and it lets astronomers test, against a real and living example, just how quickly a giant can wander inward and settle. Each young hot Jupiter is a clock on the whole process, a chance to watch the migration nearly in the act, before time smooths away every clue to how it happened. How thoroughly these worlds have reshaped the very meaning of a single ancient word is worth dwelling on quietly. For the whole long span of human history before this, the word planet meant only one of a small handful of wandering lights that drifted slowly against the fixed and patterned stars, the familiar little company of our own sun's children, countable on the fingers of two hands. The hot Jupiters and the many thousands of worlds discovered in their wake stretched that one small ancient word clear across the entire galaxy, until it had to grow large enough to hold giants that rain liquid iron, worlds hotter than some stars, planets that race around their suns in mere hours and orbit them backward and trail long tails of fleeing gas behind them. The word had to swell to fit a cosmos far stranger, far wilder, and far more crowded than anyone had ever dared to picture, and it all began with a single giant, found resting impossibly near a flame. Let the mind grow heavier now, sinking a little further down into the warmth, as the long catalogue turns toward its stranger, and finer wonders still. Some hot Jupiters circle stars that are themselves dying, or already greatly changed. Aged suns that have swollen up into vast red giants, their cooling outer layers spread thin and wide across the sky. A planet that once orbited a steady, ordinary star can find itself, after billions of years have quietly passed, circling instead a bloated red giant whose puffed and reaching atmosphere swells slowly outward toward it, until it may one day brush against the world or even swallow it whole. Astronomers have found a few hot Jupiters skimming the very swollen edges of such aging, dying stars, worlds living out the strange and final act of a long planetary life, beside a sun that has itself begun, gently, to come apart at the seams. There may well be worlds out there caught in the slow act of being swallowed even now. A hot Jupiter spiralling gradually inward, its orbit decaying by the faintest fraction across the long ages, as the tides quietly drain away its energy, will eventually be drawn too close, and the star will at last claim it for good. The planet's gas stripped away, its remnant pulled down into the fire. Astronomers have actually watched a small number of hot Jupiters whose orbits appear to be very slowly shrinking, their transits arriving a tiny fraction of a second sooner with each passing year, as if the whole world were winding gently inward toward an ending still many millions of years away. A giant caught on a long, slow, unhurried fall, its final plunge still ages and ages distant, yet written faintly, even now, in the quickening of its clock. When such a world is finally and fully consumed, it does not simply vanish from the universe without leaving a trace behind. As a planet falls at last into its star, the star itself may brighten briefly, flaring up as it swallows the world's substance, and it may carry forever afterward the faint chemical mark of exactly what it ate, a trace of rock and heavy metal mingled into its outermost layers, the quiet signature of a devoured planet written permanently into the star's own light. Astronomers have found certain stars laced with just such telltale, unexpected metals, and have wondered, looking at them, whether each one might be the lingering ghost of some world that strayed a little too near long ago, a star wearing the faint chemistry of a planet it once held and then consumed, like the memory of a meal it can no longer speak of. Some of these giants have been found, against all earlier expectation, in the quiet company of smaller worlds, sharing the same star in calmer orbits. It was long assumed that a hot Jupiter, with its violent and disruptive migration inward, would inevitably sweep the whole inner system clean of anything else, flinging aside or devouring any smaller planet that lay in its path, and in many systems that may indeed be exactly what happened. But astronomers have now found a handful of hot Jupiters that peacefully share their star with other smaller worlds, modest companions that somehow either survived the giant's arrival or quietly settled into place afterward. It is a gentle and surprising sign that even a planet's stormiest journey inward need not always leave the whole system barren behind it, and that smaller worlds can sometimes still endure in the long shadow of a giant near the flame. The stars that host these worlds come in an enormous range, and the character of each planet is shaped almost entirely by the character of its particular sun. Around a small, cool, dim red star, a hot Jupiter need not orbit so terribly close to be warmed to its simmering state, since the star it circles is itself so faint. Around a large, fierce, brilliant blue-white star, even a fairly distant giant can be roasted all the way to the ultra-hot extreme. The very same kind of planet set beside two different suns lives two wildly different lives, gently and mildly warmed over here, savagely and blindingly scorched over there, and so the whole great family of hot Jupiters spans every shade of heat imaginable, from a smouldering 1,000 degrees to the white-hot trembling edge of stardom itself, depending entirely on the single fire each one happened, long ago, to settle down beside. Return for a moment to the planet KELT 9b, the hottest of them all, and consider once more the fierce star that scorches it. That star is so blazingly hot and so luminous, and pours out such a torrent of high-energy radiation that the planet's atmosphere is not merely warmed by it, but actively eroded. The fierce ultraviolet light boiling the planet's gases steadily away into a great escaping cloud that trails through space. The world is wrapped in a vast and growing envelope of fleeing hydrogen and even fleeing heavy metals, a planet visibly evaporating in the merciless glare of one of the very hottest stars known to host any world at all. The single most extreme planet yet found circling beside one of the most extreme of suns, a giant glowing nearly as bright as the very fire that is, slowly and surely unmaking it. There is a quiet poetry in the way the heat of these worlds is so often captured by a single number that politely imagines the whole planet as a perfectly smooth and even ball. Astronomers speak of a world's equilibrium temperature, the steady warmth it would eventually settle to if all of its heat were spread perfectly and evenly across its entire surface, and if it neither made nor reflected any light of its own. It is a kind of idealized average, a useful and necessary fiction, since no real hot Jupiter is anything like even. Each one blazes fiercely on the one face and broods cold and dark on the other. But the single number gives astronomers one clean handle to grasp the heat of a world by, one tidy figure to hold up against the fierce and deeply lopsided truth of the planet itself. A whole world's climate gently distilled down into one temperature that the world, in fact, never actually has anywhere upon it. Some hot Jupiters glow more brightly than their pure heat alone should ever allow, and the long puzzle of that extra light has been a small and rather lovely mystery to chase. A few of these worlds, when measured very carefully, give off noticeably more glow than astronomers expect even after fully accounting for their temperature, as if some additional hidden process, some unseen chemistry or some deep internal churning were quietly adding to their light. The explanations that have been proposed are subtle and various. Extra heat dredged slowly up from far below, or particular metals glowing faintly in the upper air, or simply the planet's own deep infrared shining through more strongly than expected. Each measured surplus of unexplained light is a small question mark hung carefully on a distant world, a gentle and standing invitation to look just a little closer still. The reflected colours of a cooler hot Jupiter could, at least in principle, tint its whole appearance in genuinely surprising ways. Depending entirely on the particular clouds and gases that happen to wrap it, a world might throw back its starlight carrying a faint distinct cast of colour, and indeed one carefully studied planet appears to be a deep, dark, almost royal blue, not at all from any oceans, for it has none and could have none, but instead from the precise way its hazy atmosphere scatters the incoming light, and perhaps from high clouds of glass that glitter blue in the beam. A giant the deep colour of a clear twilight sky, its rich blueness born entirely of shattered minerals suspended high in a burning, roaring air, drifting dark and sapphire-toned and beautiful around its own distant, indifferent sun. That single blue world is worth resting upon a moment longer for the sheer strangeness lying just beneath its lovely and inviting colour. It is a hot Jupiter on which the temperature runs so high that silicate, the very stuff of common sand and of clear window glass, may condense out of the air into clouds, and on which the fierce winds may then fling those tiny glassy particles sideways at thousands of miles an hour. So the deep blue of that world, if you could ever truly see it up close, would be the blue of a sky entirely full of flying glass, a richly azure planet wrapped in clouds that might, on the searing dayside, rain down hard shards of silicate driven sideways on supersonic winds. Beauty and ferocity braided tightly together into one body. A world as serenely blue as a calm, clear evening, and as fierce and cutting as anything else in all the sky. The way these planets are weighed and measured and mapped, all without ever once being touched, is a marvel of patient human cleverness worth admiring. From the gentle wobble of the parent star, astronomers carefully tease out the planet's mass. From the depth of its transit shadow, they read its true size, and from those two figures held together, they can work out its density, and so learn at once whether it is a puffed and airy giant, or a dense and tightly packed one. Every bit of it deduced entirely from afar, from the faint trembling of distant starlight, and the small, regular dimming of a faraway sun, without a single probe ever crossing the vast gulf that lies between. The full physical portrait of a world unreachably far across the dark, its weight, its width, its very substance, drawn out completely and confidently from nothing but the patient behaviour of its light. The breathing may slow on its own as the wonders turn now toward the very largest patterns, the great shapes that emerge only when all of these scattered worlds are viewed together at once. Astronomers have noticed a curious empty gap running through the whole catalogue. A desert, they have come to call it, a particular range of orbits and sizes where remarkably few hot Jupiters are ever found at all, as though some worlds had simply been swept clean out of that one zone. It may well mark the very place where giants that wandered in just a little too close were stripped of all their gas, or pulled entirely down into their stars and lost, leaving behind only an empty band in the great family portrait of the worlds, a missing stripe in the broad distribution of planets, and a quiet, telling sign of giants that surely once lived there, and that live there no longer. There is a kindred gap among the much smaller worlds that the hot Jupiters themselves help us to understand. Among the planets just a little larger than the Earth, and a little smaller than Neptune, there runs a strange scarcity of worlds at one very particular size, a clear valley in the count, thought to be carved out by starlight steadily stripping the atmospheres off whichever planets are caught within it, leaving bare rocky worlds below the gap and puffed gassy ones above it, but very few worlds in between the two. The same fierce stellar radiation that boils the lightest air off a hot Jupiter, working patiently on far smaller worlds, sculpting and shaping the entire population of planets across the galaxy by quietly deciding which of them get to keep their skies and which do not. The fire, in the end, shapes the whole family of worlds. The very existence of so very many hot Jupiters whispers something gentle and almost reassuring about chance and circumstance. Each single one of them is the long-delayed ending of its own particular private story. A giant born far out in the chill of the dark, set adrift by some passing gravitational nudge or by the slow, patient drag of its birth disk's gas, then journeying inward across many millions of years to come, at last, to rest beside a star. No two of those long journeys were ever quite the same, and so the worlds that finally resulted from them vary endlessly, one from the next. This one puffed and airy, that one dense and heavy, this one blazing white hot, that one merely warm, this one orbiting straight and true, that one tilted hard or running entirely backward. a whole vast gallery of giants, and each one shaped uniquely by its own private and unrepeatable history of drift and capture and fire. Astronomers can sometimes read, in the very chemistry of a hot Jupiter's air, a faint clue to where in its own system the world was first born. The exact mixture of certain key elements, how much carbon there is compared to oxygen, how much of the heavier metals are present and in what proportion, carries within it a kind of faint chemical memory of the particular part of the birth disk from which the planet first gathered its gas and ice, whether near the warm star or far out in the deep cold. By carefully reading those subtle ratios written into the starlight, astronomers can begin to work out a world's original cradle, tracing its long inward journey backward step by step, all the way to its distant origin. A planet's faraway birthplace, quietly inferred from the elements it still carries with it, light years and long ages later. The slow rise and fall of a hot Jupiter's brightness as it orbits, what astronomers call its light curve, holds a surprising wealth of quiet information far beyond the simple dip of the transit alone. As the planet circles its star, the total glow we gather from it swells and shrinks smoothly, the world showing us a little more of its hot, bright day side, and then a little more of its cold, dark night, a gentle waxing and waning very like a tiny distant moon slowly passing through all its phases. And from the exact shape of that rising and falling curve, astronomers can read out the temperatures of both faces of the world at once, the speed and the direction of its great winds, and even the precise offset of its hottest point from high noon. An entire planet's weather, faithfully written in the slow, steady breathing of its light across just a few days of orbit. There is a deep and quiet wonder in the simple thought that all of these distant worlds were forming at the very same time our own sun's planets were forming, out of disks very much like the one that long ago made us. Every single hot Jupiter began its life inside a great flattened disk of gas and dust slowly swirling around a young new star, precisely the same kind of swirling disk from which the Earth and Jupiter and all the rest of our own worlds were gathered together 4.5 billion years ago. The hot Jupiters are not freaks born of some alien and unfamiliar process. They are the natural products of the very same planet making that built our own quiet home, simply run with different timing, inside different disks and ending up resting in very different places. They are our true cosmic cousins, born of the same kind of swirling cradle, grown only to a far stranger and fiercer fate. The strangeness of that kinship is worth letting settle softly into the dark. Somewhere in the deep and unrecorded past of our own system, our own Jupiter may itself have begun long ago to wander slowly inward, drawn starward by the gas of the young sun's surrounding disk, before something gently checked it, perhaps the steady gravitational pull of Saturn drawing alongside it in a slow, orbital dance, and tugged it patiently back outward again to the safe cold orbit it has faithfully kept ever since. Had that ancient dance simply gone a little differently, had Jupiter not turned back when it did, our own great giant might itself have become a hot Jupiter, and the inner worlds, the small rocky Earth among them, might never have come to form at all. We may in truth owe the very ground beneath us to a single great planet that wandered toward the fire, and then, by the grace of another, quietly came home. The swift orbits of these worlds, regular as they are, have let astronomers measure time itself in delicate new ways. Because a hot Jupiter transits its star so very often, and so perfectly regularly, each one of its crossings serves as a faithful tick of a kind of cosmic clock, and so the very tiniest variations in the timing of those ticks can quietly reveal the presence of an unseen companion world, one whose hidden gravity tugs the visible giant a few seconds early on one orbit and a few seconds late on the next. By watching closely for those faint hesitations in the great steady rhythm, astronomers have managed to weigh whole planets they could never otherwise have detected at all, sensing the silent presence of hidden worlds purely through their gentle gravitational pull upon the giant we can see, a planet found not by its own light nor its own shadow, but only by the way it ever so slightly nudges the clockwork of another. The very first measurements ever made of a hot Jupiter's atmosphere were taken by watching starlight filter delicately through its air, and the technique carries a fineness that is easy to overlook entirely. As the planet crosses the face of its star, a thin ring of starlight passes through the very outermost edge of the planet's atmosphere on its long way toward us, just grazing the planet's high, thin outer air. And in that brief grazing passage, the gases up there quietly imprint their own chemical signatures upon the light. Astronomers learned, remarkably, to read an entire atmosphere from a mere sliver of starlight that had done nothing more than softly brush the curved rim of a world in passing. The very faintest passing touch of a star's beam against the edge of a distant planet, carrying within it the full secret recipe of a whole alien sky. Some of these worlds turn out to be wrapped in a smooth, featureless haze that quietly hides their secrets away, and even that frustrating blankness is, in its own way, a kind of discovery. When astronomers spread the gathered light of certain hot Jupiters out into a careful spectrum, they sometimes find not the sharp, clear fingerprints of particular gases at all, but only a flat, smooth, unhelpful curve, the unmistakable sign of a high deck of cloud or haze drawing a thick grey veil across all the deeper air below it, hiding the planet's true chemistry from view. A world that keeps its own counsel, wrapped close in a fog that blurs away its every signature, telling the watching astronomers only that something hangs high and opaque in its sky, guarding the deeper weather of the planet jealously from the long reach of the light. The migration of these giants, once such a radical and unwelcome idea, is now seen everywhere astronomers look across the heavens, and the picture of it has grown wonderfully rich and varied with time. Some hot Jupiters appear to have drifted slowly inward through the gas of their own birth disk, gentle and early and unhurried. Others were clearly flung violently inward instead by sharp gravitational encounters, and only later tamed and rounded by tides. And the two very different paths leave behind two very different marks: a smooth, circular, neatly aligned orbit for the gentle early drifters, and a steeply tilted, or stretched, or even fully reversed orbit for the ones that were thrown. By carefully reading the precise shape and the tilt of a hot Jupiter's orbit today, astronomers can often tell, after all this time, just which kind of long journey first brought it home. The whole violent or gentle history of a world, still plainly legible in the quiet geometry of its path. There is something deeply steadying in how thoroughly these once impossible worlds have, with time, become entirely ordinary to science. What began back in 1995 as a single baffling anomaly, one lone giant resting exactly where no giant could possibly be, is now a thoroughly well-mapped class of hundreds upon hundreds of worlds, complete with its own textbooks, its own competing theories, and its own dedicated sky surveys. The initial shock has long since softened into settled knowledge. The flatly impossible has quietly become the routinely expected, and that, in the end, is precisely how the great frontier of human understanding always moves forward. A single thing that once overturned absolutely everything, studied long enough and patiently enough, gradually becomes simply another familiar part of the furniture of the known, and the wonder itself drifts onward to whatever new strangeness lies just beyond. It is worth drifting for a moment toward the people who first truly felt the strangeness of these worlds, back at the very beginning. When Michel Mayor and Didier Queloz first saw their chosen star wobbling with that steady 4-day rhythm, the result was so wildly unexpected that the two of them checked it over and over again, half fearing the whole time some hidden error in their instrument, before they finally dared to believe that a giant planet could truly circle a star so impossibly close. Others before them had very nearly glimpsed the same startling thing in their own data, years earlier, and had quietly talked themselves out of believing it, simply unable to credit a planet existing where all the theory of the day firmly forbade one. It took real courage to trust a strange new measurement over a comfortable old expectation, and that single act of trust swung open the door to an entire galaxy of worlds. Sometimes the universe quietly rewards nothing so much as the simple willingness to be astonished. The first discovery rippled swiftly outward into a great flood, and there is a gentle gathering momentum in recalling just how fast it all grew. Within only months of 51 Pegasi b, other teams of astronomers had confirmed several more hot Jupiters circling other distant stars. Within just a few short years there were dozens of them known, and within a single decade, hundreds, as survey after survey turned its patient gaze upon the heavens and found giant after giant after giant, each one winking and tugging faithfully at its own sun. The single hairline crack in the old settled picture of the cosmos became, almost overnight, a roaring torrent of brand new worlds, each one arriving a little less surprising than the last, and yet all of them together amounting to a complete and irreversible transformation. An entire science remade from the ground up within one human generation, beginning with just one faint star that simply would not hold still. Some hot Jupiters orbit so swiftly and lie so impossibly close to their stars that their entire years rank among the very shortest known for any planet of any kind, anywhere at all. There are worlds out there that complete one full orbit in well under a single Earth day, in only 18 hours or 16, and in the most extreme known cases even less than that, racing all the way around their stars in less time than a person spends in one good long night's sleep. A creature somehow standing on the eternal day side of such a world, were it able to look up and watch, would see its own star wheel completely through the entire sky and return again to where it began, over and over and over, faster even than the slow hours of a single quiet night here on Earth. A whole year, shorter than one day, a phrase that should by all rights make no sense at all, and yet is the simple, plain, measured truth of these innermost racing giants. The sheer scale of these worlds set against their tiny swift orbits is a thing to hold in the deepening quiet of the night. A hot Jupiter is a single globe more than 80,000 miles across, wider even than the great giant of our own sky, and yet it whirls around its star along a circle so impossibly tight that the whole vast planet sweeps along its path at hundreds of times the speed of a rifle's bullet. Great size and great swiftness married together in a way that nothing in all of our own calm and orderly system can begin to match. A world fully the size of the largest planet we have ever known, racing around its sun far faster than the eye or the mind could ever follow it, and doing so over and over tirelessly, without the slightest pause or rest for billions upon billions of years. The fierce atmospheres of these worlds, for all their roaring violence, settle in the end into patterns that careful study can actually predict, and there is a real comfort hidden quietly in that fact. Beneath all the apparent chaos of supersonic winds and vaporizing metals and shattering molecules, the climate of a hot Jupiter obediently follows rules. The heat streams steadily from the bright face around toward the dark in a single great jet. The hottest spot always settles a fixed distance downwind of high noon. The clouds reliably form just where the temperature crosses certain known lines. Astronomers can now build careful models of these worlds and predict, before they even look, roughly what they expect to find waiting there. The wildness, it turns out, has a grammar all its own. The raging storm keeps faithfully to deep laws, and those laws, once truly known and understood, make even the very fiercest of these worlds into a place the mind can finally rest upon in peace. There is a particular and unexpected stillness in considering just how utterly unchanging these worlds are, despite all of their endless violence. A hot Jupiter, locked forever to its star, blazing on the one face and dark on the other, has held very nearly the exact same configuration for billions of years already, and will go on holding it for billions more to come. The day side does not cool, the night side does not warm, the great winds do not change their steady direction, the single hottest spot does not wander from its place. It is a furious kind of permanence, a raging storm that has been blowing entirely unchanged since well before the earth beneath you was even solid rock, and yet somehow in its very sameness and its deep constancy, there lives a profound and settling calm. The particular calm of a thing that has long, long ago found its final shape, and that will simply never, ever let it go. Sink a little deeper still now, toward the last gentle handful of wonders, the ones that touch on light and colour and the softer edges of these fierce and distant worlds. The glow pouring off a hot Jupiter's sunlit face, when it is carefully spread out and studied, reveals not any single flat colour at all, but a whole continuous spectrum of warmth, every shade running from the deepest infrared red, up through all the visible colours, and on the very hottest worlds reaching clear into the blue-white. And simply by reading where within that broad spread the glow shines brightest, astronomers can take the temperature of the world as surely and as confidently as any thermometer pressed to a brow. For everything that glows by its own heat alone glows in a colour set precisely by exactly how hot it is. The cherry red of a cooler world, the white blaze of an ultra-hot one. A whole planet's warmth, written out plainly and openly in the simple colour of its own light. The transit of a hot Jupiter across the bright face of its star can even quietly reveal the true shape of the planet itself, ever so slightly out of perfect round. A world that is being constantly squeezed by the powerful tides of its nearby star is not a flawless sphere at all, but a very faint egg, drawn gently out along the invisible line that points toward the star. And as that slightly stretched world crosses the disk of its sun, the precise and careful pattern of the dimming carries within it the faint trace of exactly that small distortion. From only the most painstaking measurements of a transit's shape, astronomers can actually detect that a planet is not quite perfectly round, can sense, across hundreds of light years of empty dark, the gentle stretching of a whole world by the steady gravity of its sun. The tidal egg shape of a distant giant, read delicately in the very fine grain of a passing shadow. Some hot Jupiters lie close enough to fierce enough stars that their day sides may glow faintly, even to the kind of instrument that watches only for the colours of the ordinary rainbow we can see with our own eyes. The very hottest of these worlds, blazing past 4,000 degrees, give off a real and genuinely measurable share of their total light directly in visible colours, not merely in the warm hidden infrared, so that, at least in principle, the day side of an ultra-hot Jupiter shines with a glow that a human eye could very nearly register on its own. A deep, dim, sullen red light, born wholly and entirely of the planet's own fierce internal heat. A world that does not merely catch and reflect the daylight of its star, but actually makes a faint daylight all of its own, glowing steadily out into the surrounding dark like a single great coal that simply never goes out. These fierce worlds have served all along as the great proving ground for learning to study any planet's air at all, and that quiet role deserves its own gentle recognition, precisely because they are so large, so very hot, and so close to their bright stars the hot Jupiters give off the strongest possible signals of any planets known, the deepest transits, the brightest glow, the clearest and sharpest spectral lines. And so it was upon these worlds, naturally, that astronomers first learned the difficult art of reading an alien atmosphere at all. Every single technique now being carefully turned upon smaller, cooler, more Earth-like worlds was first sharpened and tested and proven on a hot Jupiter, the loud and brilliant giant patiently teaching us how to listen, long before we ever dared to try to hear the far quieter worlds. The fiercest planets in all the sky became in the end our very gentlest of teachers. There is a kind of quiet music in the way astronomers have learned to separate a planet's own faint light from the utterly overwhelming blaze of its star. By patiently watching the combined light of star and planet shift ever so slightly as the planet swings toward us and then away again, a fine, subtle sliding of all the colours, the very same effect that betrays any source moving closer or farther, they can carefully pick the planet's own small glow back out of the mixture, isolating the faint whisper of the distant world from the deafening roar of its sun. It is rather like learning to hear one single, soft and particular voice buried deep within a great swelling chord of music, and then drawing it out cleanly by the subtle way it alone rises and falls in pitch as the planet slowly circles. The faint and lonely song of a far-off world, gently untangled at last from the loud, bright music of its star. From the ground, too, beneath all our shimmering air, astronomers have found a way to pull the planet's glow free of its star, and the trick of it is wonderfully simple at heart. As a hot Jupiter races around its star at 100 miles a second and more, its own faint light carries the fingerprints of its own gases, and those fingerprints shift steadily in colour as the world hurtles first toward us and then away again, sliding in pitch, in effect, far faster than the slow-moving star ever could. By gathering the light at the very finest resolution and watching for a whole forest of faint lines, all marching together in step with the planet's swift orbit, astronomers can lift the planet's signal cleanly away from the stars. They have caught this way the glow of iron and of water and of carbon riding in alien skies, the planet betraying itself purely by how fast it moves. What these distant fires quietly mean, in the end, is worth letting the thought soften toward as the night grows late. The hot Jupiters taught us, more powerfully than any other single discovery before or since, that our own particular arrangement of worlds is not at all the master template of the entire cosmos, but only one quiet variation among countless uncounted others. The careful, ladder-like order of our own solar system, small rocky worlds tucked safely in, great gas giants kept far out, everything moving in neat circles, all of it aligned and serene, turned out to be just one single note within a vast and wildly varied music, played out a little differently around very nearly every star in the sky. There was a real humility waiting quietly in that lesson, and a deep wonder folded inside it too. The slow realization that the heavens are far, far more inventive than our own small backyard had ever once allowed anyone to imagine. There is a real comfort to be found in the simple thought that for every single blazing hot Jupiter ever found, there are surely countless far gentler worlds still waiting, entirely unseen. The fierce giants near the flame were only the very first and the very easiest of all worlds to find, precisely because they are so extreme in every way, so loud, so large, so quick, so impossible to miss. The far quieter worlds, the ones drifting in cooler and wider and slower orbits, the small stony ones that might just hold standing seas of liquid water, are very much harder to catch sight of, and so were found only later, or wait patiently still to be found at all. Behind every one of these fierce, hot Jupiters in the catalogue, there stand a great many calmer, milder worlds that we simply have not yet learned how to hear, a whole vast hidden population of gentle planets, keeping their cool and careful distance from their suns. The whole long story of these worlds is, when you finally stand back from it, a story above all of motion, and there is a deep and surprising restfulness in simply surrendering to that truth. Nothing at all in the heavens is ever truly fixed in place. The stars themselves drift slowly through the galaxy. Whole galaxies drift through the greater void between them, and the planets drift too, each one born in one place and quietly settling, in the end, in another, wandering across the slow ages from the cold and distant outskirts inward to the searing innermost orbits. The hot Jupiters are simply the very clearest proof we've ever found that the sky overhead is not a single, finished and frozen thing, but a long, slow, patient unfolding, a great and gentle rearrangement that has been quietly underway since long before the Earth itself, and that asks absolutely nothing of you at all, except perhaps to be softly wondered at as you let yourself go. One last broad wonder is worth letting settle gently into place before the final secret arrives. In the few short decades since that first faintly wobbling star, the hot Jupiters have grown from a single flat impossibility into a wide open doorway, the very planets that first taught us how to find other planets at all, how to read the chemistry of their distant skies, how to truly imagine whole worlds utterly unlike our own quiet home. Every smaller, every cooler, every more Earth-like world now being so carefully studied today owes its own eventual discovery directly to the techniques first tested and proven upon these blazing giants. The single, fiercest kind of world in all the sky lit the long way forward to the very gentlest, and the great search for places that might be something like home began, against every expectation, with a search that happened to find the least home-like worlds imaginable. And now the final wonder, the very last one, the one to carry softly down with you into sleep. Consider what a single hot Jupiter truly is, taken all together, gathered up whole into one thought. It is a giant of gas, born long ago in the frozen outer reaches of its own system, from the very same swirling cradle of gas and dust that patiently makes all worlds everywhere. It wandered slowly inward across unimaginable distances and unimaginable spans of time, drawn gently in by drifting gas, or else flung hard inward by the gravity of some long-vanished sibling world, until at last it came to rest, pressed close against the open fire of its star. There it locked one face forever toward an endless blazing day, and one face forever toward an endless frozen night. Its metals rose up into the air as glowing vapour, and fell again, all along the thin twilight seam, as a soft metallic rain. Its winds race supersonic around the whole globe, faithfully ferrying the heat from the bright side to the dark, and it has done all of this, quietly and faithfully and without the smallest pause, for billions upon billions of years, with no one anywhere to see it, no one to name it, no one to wonder at it at all, right up until the very last thin sliver of cosmic time, when one small blue world far across the dark grew creatures who slowly learned to feel the faint tremor of its distant pull, and to read the colours hidden in its passing light, and so came finally to know that it was even there. That perhaps is the very gentlest marvel of them all. Not that these worlds are so strange, but that they can somehow be known at all. A giant hundreds of light years away, raining liquid iron through its own burning night, has been carefully weighed and measured and fully mapped by patient minds that will never once come within 1,000 long lifetimes of touching it, known to us only through a faint stellar wobble, a small passing shadow, a subtle shift in the colours of a single stray ray of light. The universe made itself unimaginably large and unimaginably strange, and then, upon one small and ordinary world, it made something quietly able to wonder at the whole vast sweep of it. The hot Jupiters are very far away, and they are fierce beyond imagining, and they are forever well past any reach of yours, and yet, tonight, they are known to you, held softly in the mind like distant fires seen glowing across a vast dark plain at night, warm and beautiful to rest your eyes upon, and utterly, completely unable to reach you here. So let them rest now, all of them at once, the whole long catalogue of giants resting beside their flames. There is nothing left at all to learn tonight, nothing to hold on to, nothing whatever to carry forward with you into the morning light. If you are still here, drifting now at the very edge of sleep, another quiet journey is already waiting there on the screen for you, ready whenever you might wish it, or never at all. There is no need to choose between them. There is no need to do anything now. The worlds will go on turning whether you watch them or not. The iron will go on falling, softly, through the distant night. The winds will keep racing around the dark sides of 100 far-off giants, ferrying their heat from the bright to the black, exactly as they have for billions of years, exactly as they will for billions more. You do not need to remember any of it. Let the numbers go. Let the long names go. Let the great glowing worlds drift back out into the dark where they belong, far away and safe and silent. Your breathing has grown slow. Your body has grown heavy and warm. The fires are very far away now, only a soft glow at the very edge of thought. Let your thoughts settle. Let the dark be kind. Let it all grow still. And now, 101 wonders are resting with you. Sleep now. Good night.